So welcome to the video guys. In this video, we'll be starting activity 1.4 that is based on determinants. So we'll be covering question 1, 2, 3, 4 and 5. So let's get started. Here we have question 1 with us. It is saying that A is a 3 cross 3 matrix with a non-zero determinant. If the determinant of 2A is equal to K times determinant of A, then what would be the value of K? So first, let's see one property of determinant. There is one very important property that says that if you want to get the determinant of K times A, then it is equal to K to the power N multiplied with determinant of A. Now, what is N? N is order of the matrix A, of the matrix A. Now, let's come to the question now. In the question, it is given the determinant of 2A is equal to K times determinant of A. Now here, if we say, if we use this property on 2A, so it would become 2 to the power N times determinant of A is equal to K times determinant of A. And what was N? N was the order of the matrix, and it is given to us that A is a 3 cross 3 matrix. So instead of N, I should write 3 over here. Now, since it is given to me that A is not equal to 0, since determinant of A is not equal to 0, then it means I can remove determinant of A from both the sides, because then it's just a non-zero number, and I have K equal to 2 to the power 3, that is 8. So the value of K here is 8. Now let's move on to the next question. In question 2, it is given to us that A is a matrix and B is a matrix, and we have to find the determinants of A and B. So let's get started. So let's start with determinant of A. It's 2 minus 1, 1, 1 minus 3, 4, and minus 1, 0, 2. So if we expand the determinant along the row 3, so how we can do that? To do that, first we will eliminate this. We are starting with minus 1. So first we will eliminate this row and this column. So minus 1 times eliminate this row in this column. So we'll be left with this determinant over here. So it's going to be minus 1, 1, minus 3, 4. Similarly, because we use the notion plus, minus, plus. See, you can have a trick in your mind that it starts with plus from here, then it goes plus, minus, plus, minus, plus. So before writing the minus 1, the coefficient should be plus. So before writing this quantity, the coefficient should be plus. So here plus of minus 1 would result in minus 1 only. Then minus of 0 times, we eliminate this column and this row. So we'll be left with 2, 1, 1, 4. 2, 1, 1, and plus 2 of, let's eliminate this row and this column. So it would be 2 minus 1, 1 minus 3. 2 minus 1, 1 minus 3. So on expanding this determinant along the row 3, we got this. Now let's try to solve this. So I change my color to white now. So here we have minus 1 times. What would be the value of this determinant? So if you have a determinant like A, B, C, D, its value is basically A times D minus B times C. So here it's going to be minus 1 times 4, that is your minus 4, minus of minus 3 times 1, that is minus 3. So minus 4 minus minus 3. Okay, then since it is a number and a number is being multiplied with 0, so this would eventually become 0. So we need not to evaluate that. Plus 2 into this determinant. So it's going to be 2 times minus 3, that is minus 6, minus of 1 times minus 1, that is minus 1. So now we have to solve for this. we add a new slide over here. We have minus 4 plus 3, that is minus 1. So it's minus 1 times minus 1 plus of 2 into minus 6 plus 1 is minus 5. 2 into minus 5. So it's going to be plus 1 minus 10, that is minus 9. So determinant of A is minus 9. Now let's try to evaluate the determinant of B. So first let's write the B over here. It's 1, 3 minus 2. It's 1, 3 minus 2. 0, 1 minus 1. And 3, 4, 2. So if we evaluate this determinant along the column 1. So this time we are evaluating it along the column 1. So first it's going to be 1 into, let's eliminate row 1 and column 1. We'd be left with determinant of 1 minus 1, 4, 2. Now 1, we had plus over here, then it would be minus, and then it would be plus. So we'll alternate the signs. So minus of 0 into, let's remove this row, eliminate this column. We'd be left with 3 minus 2 and 4, 2. And finally, if we have plus 3 with us, this plus 3. So let's eliminate this row, this column, and we have 3 minus 2, 1 minus 1 with us. So now let's try to evaluate this. It's going to be 1 into 2 minus minus 4. It's 2 minus minus 4 minus 0. So we can eliminate this term. And then we have plus 3 times minus 3 into minus of minus 2. So it will be 1 into 2 plus 4, that is 6, plus 3 into minus 3 plus 2 is minus 1. So it's going to be 6 minus 3. That would be evaluated to 3. So here we saw that the value of determinant of A is minus 9 and the determinant of value of B is 3. So minus 9 and 3 is the correct combination for us. Yeah. Now, here the things get interesting when it is asking about determinant of AB. So see, you may feel that okay, we will have to first multiply A and B and then we'll have to evaluate their determinant. No, in such cases, this property saves us. So I'd write the property here. So the property is determinant of A into B is equal to determinant of A into determinant of B. So because these are just two scalars, so you can write the same thing as determinant of B into determinant of A as well, and that would be determinant of B into determinant of A. So your determinant of A times B is basically equal to determinant of B times A, which is again equal to determinant of A into determinant of B. That is the product of the determinant of the matrices. So here, if we want to find the determinant of AB, so it's going to be uh, determinant of A into determinant of B. So we saw the determinant of A was minus 9, the determinant of B was 3. So minus 9 into 3 is going to give us minus 27. So overall we have determinant of AB is equal to determinant of BA is equal to minus 27. So let's see which the following options is correct. So here AB is minus 27 and BA is also minus 27. So this was our question 2. Now let's move on to question 3. In the question 3, it is given to us that A is a 2 cross 2 matrix having some arbitrary values A11, A12, A21, and A22. And based on the same arbitrary values, we have to find few more matrices B, C, D, and E. So our task is to determine which among B, C, D, and E have the same determinant as that of matrix A. So first, we'll be using one property over here. And the property is, let's suppose I have a row and I'm doing the operation on row such that I'm adding or subtracting the scaled version of some other row from that row. In that case, the value of the determinant will not change. So if I have any row I with it, row I with me, and if I'm doing some operation on row I such that I'm doing row I plus or minus, you can do anything, some constant times some other row, let's call it row j. So in that case, the value of determinant will not change. Similarly, if I do any column operation like ci is ci plus some constant times some other column, column j. So in that case also the value of determinant will not change, where k is some constant, that is some real number. So now let's see what we can do here. So let's closely observe. We have our a as a11, a12, a21 and a22. Okay, and our b is a11 minus a21, a12 minus a22. So see, if we do this operation here, that if we say that our row 1, I'm doing an operation on row 1 such that row 1 minus row 2. So what would happen? It would change it to a11 minus a21, a12 minus a22, and the second row is going to remain same. So here we did a single row operation and we achieved B. This is our B. So here, as we saw that we did a row operation, and according to that property, if you do such kind of row operation, the value of determinant does not change. So that means the value of determinant of A is equal to the value of determinant of B. Now, in the same matrix A, if I do a column operation, so let's try to do it here. If I have my A equal to A11, A12, A21, A22, and I do something like an operation in column 1 is that column 1 minus column 2. So what would happen here? It would become a11 minus a12 and a21 minus a22. So it is a12 and a22. So this is, can we identify any such matrix here? Yes, this is RC. So we can also conclude that determinant of C is also equal to determinant of A. Now, let's check option D and option E. So in option D and option E, we can say that here this element we are adding, but this element we are subtracting. So no such operation was included in this property. Similarly, in matrix E as well, we are subtracting this element, but we are adding this element. So again, no such operation was mentioned here in the properties. Hence, by this property, we cannot conclude that D and E have the same determinant as the value of determinant A. But that alone is not sufficient to conclude that the determinant of A and determinant of D is not equal. For that, we will have to expand it as well. So let's try to do it. So if we expand determinant of D, it's going to be determinant of A11 plus A21 and determinant of A12 minus A22. And here we have A21 and A22. So it's basically going to be A22 multiplied with A11 plus A21 minus of A21 multiplied with A12 minus A22. And what was the determinant of A? So let's use white pen over here. The determinant of A was determinant of A11, A12, A21, A22. So what it would give us? would give us A11 into A22 minus of A12 into A21. So let's see on expanding this whether we are getting this or not. So we are getting one term of A22 into A11. Okay. And then we will get one term of A22 into A21. And here we get one term of A21 into A12 and then one term of A21 into A22. So let's see what it would become. It would basically become A11 into A22 plus A21 into A22 minus of A12 into A21 plus A22 into A21. So see, here we have few additional terms. Let's try to compare the terms. Here we have A11, A1, A22, A11, A22 we have here as well. Here we have A12, A21. Here also we have A12, A21. But we have some additional term as well. And these two terms are not cancelling out each other. These two are in addition. So it would eventually become 2 times of A21 into A22. So there is one additional term here in determinant of D. Hence we can say that determinant of D is not equal to determinant of A for any arbitrary value of A11, A12, A21, A2. And can we do something similar with E as well? Yes, we can do the similar thing with E as well. And there also we'll get to the same conclusion that the terms and determinant of E, there are some additional terms in determinant of E which are not present in determinant of A. Hence, we'd be able to conclude that determinant of A is not equal to the determinant of E. Okay. Now moving on to the next question, that is our question 4. In the question 4, it is given to us that A is some A11, A12, A13. It is some T times A11 minus S times of A31, T times of A12 minus S times of A32, and T times of A13 minus S times of A13, and then something like this. So let's see what we can do here. See, if we closely observe uh, our determinant of A, it's written as A11 T times of A11 minus S times of A31 R times of A31. Now A12 T times of A12 minus S times of A32 and RA32. We have A13, this is T times of A13 minus S times of A33. And then we have R times of A33. So let's see what we can do here. See, the first thing is, can we use the property that we just saw in the last question? So how can we use that property? So in R2, we can see there are terms of A11, A2, A12 and A13 which are already present in row 1. So from R2, if we subtract T times of row 1, so we'd be able to eliminate these terms TA1, 11, TA12 and TA13. Now we have S times of A31, S times of A32 and S times of A33. Can we do something with that as well? Okay, so if we add S by R times of R3, so what would be S by R times of R3? So because we are dividing with R, so all the R terms will get cancelled and we multiply with it S. So the coefficient will coefficient of A31, A32 and A33 will become S. So eventually we will get SA31, SA32 and SA33. So let's see what would be the result of using this operation. So if we use this operation, the result would be, okay, first of all, these two row 1 and row 2 are going to remain same because we have not done anything with them. A31 R times of A32 and R times of A33. what would happen if we subtract t times of a11? This term will get cancelled, this term will get cancelled, and this term will get cancelled. And then we add SR3, SA31, and then we add S times of A32, and then we add S times of A33. So this term will become 0, this term will become 0, and this term will also become 0. So since we have 1 0 row in our determinant, hence the value of our determinant will become 0. Okay, so you can keep that thing in your mind. If you have 1 0 row or 1 0 column, that alone is sufficient to make your value of determinant as 0. So I'd be writing the answer here as 0. Yep. Okay, here we didn't mark the answers. So answers are mm, B and C have the same value. So B and C have the same value as determinant of A. Okay, now let's move on to the question number 5. In the question number 5, again, we are given that determinant of AB is equal to 32. So first, let's try to calculate determinant of A. So now we have some multiple problems on evaluating the determinant. So let's do that. Determinant of A will be expanding along the column 1. So if we start from -1, it's going to be minus plus, oh sorry, my bad. It's going to be plus minus plus. So -1 times, eliminate this row, eliminate this column, it's going to be 1, 3, 0, -2. Now, minus of 0 times 2, you need not to write it, but write it 4 -2, 0 -2, and then you get this 1 times determinant of 4 -2, 1 and 3. Let's see what we have here. We have -1 times. If we evaluate this determinant, it's going to be -2 -0. So I'm just writing -2 over here. This is going to be 0 and plus 1 into 4 times 3 is 12 minus of -2, that is going to be +2. So you have 12 plus 2, that is 14. So you get 14 into 2, 14 plus 2, that is going to be 16. So determinant of A is 16. And what about determinant of B? So determinant of B is going to be again expanding it along row 1. So it's going to be plus, minus, plus. So if I start from 2, it's going to be 2 into alpha 0 minus 3 minus 5, and then there is some term multiplied with 0, so we need not to write that, and we can directly switch on to the last term, that is r1, r minus 1, sorry. So -1 into sorry for that, -1 into uh, eliminating this column, eliminating this row, it's 4 alpha 0 minus 3. So 4 alpha 0 minus 3. So now if we evaluate this, this is going to be 2 times of -5 alpha minus 0. So we are not writing it, plus -1 of, see, it's going to be -12. So we can write it as 12 minus 10 alpha. So we got determinant of A, we got determinant of B. In the question, it is given to us that determinant of AB is equal to 32. Okay, so determinant of AB is basically equal to determinant of A into determinant of B, that is equal to 32. So we have find the value of determinant of A, that is coming out to be 16, and then we have determinant of B, that is 12 minus 10 alpha. So if we evaluate this expression to find the value of alpha, we get okay, it is just 2 times 16. We have 12 minus 10 alpha is equal to 2. So if we put the value of alpha equal to 1, so that would satisfy this equation. So the value of alpha in this case is coming out to be 1, and that is our answer for question number 5. So in this video, we covered from question number 1 to question number 5 of our activity 1.4. So see you in the next video.